The dawn of AI scientists, how billions of autonomous researchers are set to revolutionize scientific discovery by 2025. Introduction. As the landscape of scientific research evolves, a new paradigm is emerging at the intersection of artificial intelligence (AI) and scientific inquiry. By 2025, billions of autonomous AI researchers or AI scientists are expected to dramatically enhance the pace and efficiency of scientific discovery. This report delves into the transformative impact of AI-driven platforms, particularly the groundbreaking work of FutureHouse, which is pioneering the automation of critical scientific processes. FutureHouse AI Platform, a new era of research. Co-founded by Sam Rodriques and Andrew White, FutureHouse is at the forefront of this revolution. The platform is designed to tackle the long-standing issue of declining scientific productivity exacerbated by increasing complexity and specialization in research. By automating essential tasks such as information retrieval, synthesis, chemical design, and data analysis, FutureHouse aims to free researchers from mundane tasks, allowing them to focus on creative and critical thinking. Key features of FutureHouse AI Platform. Specialized AI agents. The platform includes several specialized agents. Crow, designed for literature searches. Crow efficiently retrieves and summarizes vast amounts of scientific literature. Owl, focused on hypothesis exploration. Owl assists researchers in generating and refining research questions. Phoenix, an experimental planning agent that aids in designing and executing experiments. Finch, automates data-driven discovery in biological research. Multi-agent workflow. FutureHouse innovative multi-agent workflow was demonstrated on May 20, 2025, leading to the identification of new therapeutic candidates for conditions like dry age-related macular degeneration. Addressing scientific bottlenecks. Over the past 5 decades, scientific productivity has faced significant declines due to the overwhelming volume of literature and the increasing complexity of research. Traditional methods often leave scientists struggling to keep up with the latest findings, leading to inefficiencies in hypothesis generation and experimental design. FutureHouse founders Rodriques and White believe that the integration of AI tools can alleviate these bottlenecks. By streamlining the research process, they aim to enhance overall productivity and accelerate the discovery of solutions to pressing global challenges. The role of AI in enhancing research efficiency. Information retrieval. AI can sift through mountains of data, identifying relevant studies and synthesizing findings in a fraction of the time it would take a human researcher. Hypothesis generation. By analyzing existing data, AI can propose new hypotheses, guiding researchers toward unexplored avenues of inquiry. Experimental planning. AI agents can assist in designing experiments, ensuring that researchers optimize their methodologies and minimize wasted resources. Use cases and success stories. The practical applications of FutureHouse AI tools have already begun to manifest. Early adopters have reported significant breakthroughs in their research efforts, illustrating the platform's potential. Polycystic ovary syndrome research. One research team used AI agents to identify a gene linked to polycystic ovary syndrome, leading to new treatment hypotheses. Alzheimer's research. Another researcher developed an AI assistant using Crow to scour the PubMed database for relevant information on Alzheimer's disease, significantly enhancing their research capabilities. Parkinson's disease studies. Researchers conducting systematic reviews of genes related to Parkinson's disease found that FutureHouse tools outperform traditional methods. These cases exemplify the tangible benefits of integrating AI into scientific inquiry, highlighting how AI scientists can complement human researchers. Integration and collaboration. FutureHouse emphasizes the importance of a cohesive system where various AI agents can collaborate seamlessly. This integration enhances the capabilities of AI in analyzing complex scientific data, paving the way for a future where AI not only assists in literature reviews but also evaluates the reproducibility of findings and conducts sophisticated analyses. Future vision. Rodrigues envisions a future where AI agents will not only assist scientists but also evolve to possess tacit knowledge and advanced reasoning capabilities. This will enable them to perform more sophisticated analyses and explore complex hypotheses, ultimately transforming the scientific landscape. Timeline of key events. 1. 2019, Rodrigues completes his PhD, highlighting the need for collaborative research to boost scientific productivity. 2. 2022, the release of ChatGPT 3.5 inspires the development of more powerful AI models for scientific discovery. 3. 2024, FutureHouse launches initial AI tools. Paper QA now Crow and Has Anyone Now Owl. 4. May 1, 2025, the official launch of FutureHouse comprehensive AI platform. 5. May 20, 2025, demonstration of a multi-agent workflow leading to a new therapeutic candidate discovery. 6. June 2025, release of Ether 0, a 24B open-weights reasoning model for chemistry. Common themes and differences in perspectives. Various sources concur on the urgent need for enhancing scientific productivity through automation and AI integration. While MIT News focuses on FutureHouse specific developments and successes, other perspectives may critique the challenges within the scientific community and the ethical implications of AI in research. Despite differing emphases, there is a shared recognition of AI's transformative potential in research, underscoring a collective vision for a future where AI scientists enhance rather than replace human inquiry. Conclusion. The dawn of AI scientists heralds a significant shift in how research is conducted, promising to overcome existing challenges and significantly enhance the pace of scientific discovery by 2025. With platforms like FutureHouse leading the way, the integration of AI into scientific inquiry is set to revolutionize the research landscape, enabling researchers to focus on what they do best: innovating and solving complex problems. As we look forward to this new era, the possibilities for scientific advancement are boundless, paving the way for breakthroughs that can address some of humanity's most pressing challenges. The future of research is not just human, it is a collaborative endeavor between human ingenuity and AI capability. The content discusses the rise of AI scientists, particularly through the innovations brought by FutureHouse, which is set to transform scientific discovery by 2025. Here are some counterintuitive insights drawn from the material. 1. Increased complexity versus declining productivity. While one might assume that the increasing complexity of scientific research leads to greater advancements, the data suggests the opposite. Scientific productivity has been in decline over the past 50 years, indicating that as research becomes more intricate, it becomes harder for scientists to keep pace with the literature and synthesize findings. This challenges the notion that complexity always equates to progress. 2. AI as a solution to human limitations. It might seem counterintuitive that automated systems could outperform human researchers in literature reviews and data synthesis, areas traditionally dominated by human intellect and insight. However, FutureHouse AI agents such as Crow and Owl have been shown to enhance productivity and assist scientists in making discoveries that would be arduous for human researchers alone. 3. AI integration, not replacement. Many fear that AI could replace human researchers. But FutureHouse model suggests a collaborative approach where AI acts as an assistant rather than a substitute. This partnership could allow scientists to focus on higher-level analysis and creative hypothesis generation instead of getting bogged down in data retrieval and synthesis. 4. The role of natural language in science. The assertion that natural language is the real language of science challenges the trend toward specialized machine learning models that focus on biological or chemical data. This highlights a counterintuitive understanding that effective scientific communication and reasoning still primarily rely on natural language, which AI can leverage to enhance scientific discourse. 5. Ethical and organizational challenges. While the introduction of AI tools like those from FutureHouse promises efficiency, it also raises concerns about ethical implications and the need for new organizational structures in scientific research. The belief that technology automatically leads to better outcomes overlooks the complexities of human factors, ethical considerations, and institutional inertia in adapting to new technologies. 6. Access to AI tools. The notion that simply providing scientists with AI tools will lead to productivity gains is counterintuitive. It implies that access alone can solve deeper systemic issues in scientific research, such as collaboration and communication barriers, which may not be resolved by technology alone. 7. The potential for bias in AI. The expectation that AI will operate without bias is misleading. The model's effectiveness depends on the quality of data they are trained on, which can include biases present in the scientific literature. This suggests that while AI can enhance research, it can also perpetuate existing biases unless carefully monitored and managed. 8. The speed of discovery versus the quality of insight. There is a belief that faster discovery through AI will inevitably lead to better scientific insights. However, the rush to produce results might lead to superficial understandings rather than deep, meaningful scientific progress. This poses a challenge to the quality of research outputs when speed is prioritized over thoroughness. 9. Over-reliance on AI in scientific inquiry. The reliance on AI tools may encourage a dependency that stifles critical thinking and creativity among researchers. This counterintuitive perspective suggests that while AI can enhance research efficiency, it might also diminish the intellectual rigor and curiosity that drives scientific inquiry. In summary, the rise of AI scientists presents a complex interplay of potential benefits and challenges that may defy conventional expectations about productivity, collaboration, and the nature of scientific inquiry itself. The report on the emergence of AI scientists, particularly through the innovations spearheaded by FutureHouse, presents several critical insights that many readers may overlook. Here are the essential points that deserve closer scrutiny, along with their significance in the context of scientific discovery. 1. Declining scientific productivity. One of the report's underlying themes is the concerning trend of declining scientific productivity over the past 50 years. This decline is attributed to the increasing complexity and specialization of research. Scientists face an overwhelming number of publications, making it challenging to synthesize information and draw coherent conclusions. This bottleneck is significant because it highlights a systemic issue in the scientific community that AI tools like those from FutureHouse aim to address. By automating literature reviews and data synthesis, AI could potentially restore the pace of scientific discovery, which is crucial for addressing global challenges such as health crises and climate change. 2. AI as collaborative tools. The report emphasizes the collaborative nature of FutureHouse AI agents like Crow and Owl, which work together in a multi-agent system. This collaboration is noteworthy because it represents a shift from viewing AI merely as a tool for individual tasks to understanding it as a collaborative partner in research. This perspective could change how scientists approach their work, fostering an environment where AI and human researchers can engage in a more synergistic relationship. This integration can enhance the quality of research outputs and may lead to breakthroughs that would be difficult for human researchers to achieve alone. 3. Emerging success stories. While the report lists certain success stories from early adopters of FutureHouse technology, it's important to analyze what these successes represent for the broader scientific community. For instance, identifying a gene related to polycystic ovary syndrome or developing a treatment hypothesis for Alzheimer's disease demonstrates not just the capabilities of AI but also the potential for AI to inspire new lines of inquiry and exploration. These case studies are significant as they serve as proof of concept for the effectiveness of AI in generating new hypotheses and accelerating the research process, potentially leading to real-world applications that impact public health. 4. Integration of AI in scientific methodology. The report discusses the future vision of FutureHouse, where AI agents will not only assist in literature reviews but also test the reproducibility of scientific findings and conduct sophisticated analyses. This point is significant because it raises questions about the validity and reliability of research findings. The ability to automate the testing of hypotheses and replicate studies could address one of the major criticisms of contemporary science, the reproducibility crisis. If AI can enhance the reproducibility of results, it would restore trust in scientific findings and lead to more robust and credible research. 5. Ethical considerations and oversight. While the report does not delve deeply into the ethical implications of employing AI in scientific research, this is a crucial area that warrants attention. The deployment of AI technologies raises questions about data privacy, bias in AI algorithms, and the potential for misuse. As AI becomes more integrated into research processes, the scientific community must ensure that ethical standards are upheld. The significance of this oversight cannot be understated, as it will shape public perception and acceptance of AI in science. The absence of robust ethical frameworks could hinder progress and lead to public distrust in AI-driven research outcomes. 6. Long-term vision for AI in science. FutureHouse founders have a long-term vision for embedding tacit knowledge into AI agents, allowing them to perform more sophisticated analyses. This ambition is noteworthy because it reflects a shift towards creating AI systems that not only process information but also understand context and nuance in scientific inquiry. The ability to integrate tacit knowledge could make AI agents more effective collaborators, leading to an evolution in how research questions are framed and explored. This vision signifies a transformative potential for scientific discovery itself, as it could redefine the boundaries of what research can achieve. 7. Infrastructure for AI integration. The report mentions the necessity of building infrastructure to allow agents to use specialized tools for science. This point is significant as it highlights the logistical and technical challenges that must be overcome for AI to be fully integrated into scientific workflows. The development of such infrastructure will be critical in determining how effectively AI can enhance scientific productivity and discovery. Moreover, it underscores the need for interdisciplinary collaboration between AI specialists and domain experts to create tools that genuinely meet the needs of researchers. Conclusion. The report on FutureHouse and the dawn of AI scientists reveals transformative potential in scientific discovery by 2025. However, it is crucial to recognize the nuances and implications of these developments. The decline in productivity, the collaborative nature of AI, emerging success stories, the integration of AI and methodologies, ethical considerations, long-term visions, and infrastructural needs are all critical elements that could shape the future of research. By paying attention to these aspects, stakeholders in the scientific community can better prepare for the challenges and opportunities that AI presents, ultimately leading to a more efficient and robust scientific enterprise. 1. Automation of scientific processes, the role of FutureHouse AI platform. The FutureHouse platform, co-founded by Sam Rodriques and Andrew White, exemplifies the cutting edge of AI in scientific research. By automating critical processes such as literature retrieval, data synthesis, chemical design, and experimental planning, it addresses the significant decline in scientific productivity observed over the past 50 years. This automation is not merely about efficiency, it fundamentally changes how research is conducted. The integration of various specialized AI agents, like Crow for literature searches, Owl for hypothesis generation, and Phoenix for experimental planning, creates a multi-agent workflow that enhances collaboration and accelerates the discovery of new therapeutic candidates, as evidenced by its success in identifying a treatment for dry age-related macular degeneration. 2. Addressing scientific bottlenecks and enhancing productivity. The decline in scientific productivity has been attributed to increasing complexity and specialization within research. FutureHouse aims to mitigate these challenges by equipping researchers with sophisticated AI tools that alleviate the burden of information overload. Rodriques and White argue that traditional approaches to research are insufficient in today's landscape, where scientists struggle to synthesize vast amounts of literature into coherent theories. By providing AI-driven solutions, FutureHouse not only streamlines the research process but also empowers scientists to tackle more ambitious and complex problems, ultimately leading to breakthroughs that were previously unattainable. 3. Use cases and empirical success in research. The practical application of FutureHouse AI tools has already yielded significant results. Early adopters have successfully utilized AI agents to make discoveries such as identifying genes associated with conditions like polycystic ovary syndrome and developing AI assistants for Alzheimer's research. These success stories not only validate the effectiveness of AI in scientific inquiry but also demonstrate the potential for wider adoption across various fields. The tangible outcomes serve as compelling evidence that AI can play a critical role in enhancing research capabilities, thereby incentivizing more scientists to integrate AI tools into their workflows. 4. The future of integrative AI in science. Looking ahead, FutureHouse envisions a future where AI agents not only assist in literature reviews but also engage in more complex tasks such as testing the reproducibility of scientific findings and conducting sophisticated analyses. The emphasis on creating a holistic system of collaborative AI agents represents a paradigm shift in scientific inquiry. This integration of information and collaboration among multiple AI models is crucial for understanding and analyzing complex scientific data. As AI continues to evolve, the potential for these tools to revolutionize research by providing deep insights and facilitating interdisciplinary collaboration becomes increasingly apparent, paving the way for a new era in scientific discovery. 1. The Manhattan Project 1942–1946. The Manhattan Project was a secret U.S. government research project during World War II aimed at developing the first nuclear weapons. It brought together some of the most brilliant scientific minds, including J. Robert Oppenheimer, Enrico Fermi, and Richard Feynman, along with vast resources and collaboration among scientists, engineers, and military personnel. The project exemplified how organized collaboration, accelerated research, and the integration of various scientific disciplines could lead to groundbreaking discoveries, ultimately resulting in the atomic bomb. The Manhattan Project had profound implications for science warfare and international relations, illustrating both the potential and peril of scientific advancement. 2. The Human Genome Project 1990–2003. Launched in 1990, the Human Genome Project (HGP) aimed to map the entire human genome, identifying all the genes and their functions. It was an international collaborative effort involving scientists from around the world, including the US, the UK, Japan, France, Germany, and China. The HGP utilized cutting-edge technology and massive data analysis techniques, leading to significant advances in genomics, biotechnology, and personalized medicine. Its completion in 2003 marked a monumental achievement in scientific research, providing foundational knowledge that has transformed fields ranging from medicine to anthropology. The HGP demonstrated how collaboration and the integration of advanced tools can accelerate scientific discovery and enhance our understanding of human biology. 3. The Apollo Program 1961–1972. The Apollo program was a series of space missions conducted by NASA, culminating in the first manned moon landing in 1969. It showcased the power of interdisciplinary collaboration as it united scientists, engineers, and technicians from various fields to achieve a common goal. The program not only advanced space exploration but also led to significant technological innovations in scientific knowledge, such as developments in materials science, computer technology, and telecommunications. The Apollo missions exemplified how ambitious goals, large-scale collaboration, and cutting-edge technology could push the boundaries of human knowledge and capability, reflecting the potential for collective efforts in scientific discovery. The dawn of AI scientists, future outlook on scientific discovery by 2025. As we approach 2025, the landscape of scientific research is on the brink of a transformative shift driven by the rise of AI scientists and platforms like FutureHouse. This summary outlines the anticipated developments and their implications for the future of scientific discovery. 1. Widespread adoption of AI tools in research. By 2025, it is expected that AI-driven platforms will become integral to scientific research across various disciplines. FutureHouse AI agents such as Crow Owl and Phoenix will empower researchers to automate literature searches, hypothesis generation, and experimental planning. This widespread adoption will not only enhance productivity but also democratize access to advanced research tools, allowing even small labs with limited resources to compete in groundbreaking discoveries. 2. Enhanced collaboration and interdisciplinary research. The integration of AI and research will foster greater collaboration across disciplines. AI agents will facilitate communication between diverse fields, enabling researchers to synthesize insights and methodologies from various domains. This interdisciplinary approach is likely to lead to novel solutions for complex challenges such as climate change, public health crises, and technological advancements. The collaborative nature of AI tools will encourage more open science initiatives where data and findings are shared transparently. 3. Improved reproducibility and validation of research. A significant concern in the scientific community has been the reproducibility of research findings. FutureHouse envisions a future where AI agents can autonomously test the reproducibility of results and validate conclusions drawn in research papers. By 2025, it is likely that these AI systems will be capable of running simulations and experiments based on existing data, providing a robust mechanism for verifying scientific claims and enhancing the credibility of published studies. 4. Accelerated discovery of therapeutics and innovations. The potential of AI to analyze vast datasets quickly will lead to accelerated discovery timelines for new therapeutics and innovations. For instance, FutureHouse's demonstration of a multi-agent workflow that identified a new therapeutic candidate for age-related macular degeneration illustrates the speed at which AI can drive discovery. By 2025, we can anticipate a surge in the identification of novel compounds and treatments, significantly impacting healthcare and pharmaceutical industries. 5. Ethical considerations and responsible AI use. As AI systems become more embedded in scientific discovery, ethical considerations will be paramount. Researchers, developers, and policymakers will need to establish guidelines to ensure that AI is used responsibly and transparently. By 2025, it is expected that frameworks will be in place to address issues such as data privacy, algorithmic bias, and the ethical implications of AI-driven research. Collaborative efforts between scientists, ethicists, and AI developers will be crucial in shaping the responsible use of AI in science. 6. AI as a co-researcher and collaborator. The role of AI is evolving from a mere tool to that of a co-researcher and collaborator. By 2025, AI agents will not only assist in data analysis and literature reviews but will also engage in hypothesis generation and experimental design. Researchers will increasingly rely on AI for creative insights, effectively blurring the lines between human and machine contributions to scientific inquiry. This partnership will enhance the scope of research questions tackled and may lead to breakthroughs that were previously unimaginable. 7. Continuous learning and adaptation of AI agents. FutureHouse vision includes the continuous learning and adaptation of AI agents. By 2025, these systems will be equipped with the ability to integrate new findings and methodologies, ensuring that they remain at the forefront of scientific inquiry. This adaptability will allow AI agents to refine their algorithms, improving their performance and relevance in an ever-evolving research landscape. 8. Global impact and accessibility of research. The democratization of AI tools in scientific research will have a global impact. By 2025, researchers in developing regions will have access to powerful AI-driven platforms, enabling them to contribute to global scientific knowledge. This increased accessibility will help bridge the gap between resource-rich and resource-poor research environments, fostering innovation and collaboration on a global scale. Conclusion. The dawn of AI scientists heralds a new era of scientific discovery marked by unprecedented efficiency, collaboration, and innovation. As we approach 2025, the integration of AI tools like those developed by FutureHouse promises to enhance productivity, improve the reproducibility of research, and accelerate the discovery of new therapeutics. However, alongside these advancements, ethical considerations and responsible use of AI will be critical to ensuring that the benefits of this technology are realized for all. The scientific community stands at the cusp of a revolution, ready to embrace the possibilities that AI offers for the future of research.